All right, in this lesson we're going to be talking about the tangent ratio. So here we have a room addition that I was building, and over here we have what's called a rake wall. And up on this rake wall we have a right triangle. See that? And so in this right triangle here, we actually got a whole bunch of right triangles. A little right triangle here, little right triangle here, all kinds of right triangles going on. And if we look closely, what do you notice about all these right triangles? I can't trace it very well. But what do you notice about all these things? Well, they're all similar triangles. Okay? So they all are right triangles, of course. I just said that. And they all have the same angle down here. So angle, angle, if you remember, that makes triangles similar. So these triangles are all similar. And what do we know about similar triangles? We've studied two things. We know that the angles are congruent and the sides are proportional. And it turns out that the way this house was designed is that it has what we call a 5-12 pitch, which means if we go a rise of 5, we have a run of 12. It's basically, what is that rise and that run? Oh yeah, that's slope, right? So it's basically slope. So the pitch of a roof is just a slope, and we call it 5-12. That means we go up 5 inches. If we go up 5 inches, we're going to go over 12 inches. If we go up 5 feet, we go over 5 feet. Or up 5 millimeters. I don't know how you go up milliliters, but you go up 5 millimeters, you're going to go over 12 millimeters. Whatever unit doesn't matter. We're going to go up 5 for every 12 we go over. Okay, and we could use a little Pythagorean theorem, and it turns out that this is going to be a 13. So that's a really nice roof pitch that ended up because it's a Pythagorean triple. But anyways, back to similar triangles. We've got these similar triangles here. And we know that, again, since they're similar, well, they are similar because of angle, angle. And so these third angles all have to be the same as well. So all these little angles up here would all be congruent. So similar triangles have angles that are congruent, and they've got sides that are proportional. All right? So I don't know about all these sides, but I know they're proportional. Okay? They're all proportional to this 5-12. I don't know if any of these actually are 12, but whatever they are, they're in the same ratio. Okay, so let's think about this. Here we've got a few triangles, and the question is, can you find some missing parts? Okay, so can you find missing parts on here, on this left one? Okay, so all right, can we find the missing angles? Well, of course we can. All right, we know they all add up to 180, so these two angles actually have to add up to 90, so this is going to be looks like 73.4 degrees. So sure, we could find that missing angle there. What about this guy? Can we find the missing side? Sure, we've got this tool called the Pythagorean Theorem. So we've got 5 squared plus 12 squared equals c squared. And if we solve that, that's going to come out to be 13. So we got the Pythagorean Theorem, and we know the fact that opposite sides or all the angles add up to 180. So two tools, we can find a missing angle, we can find a missing side. But how about this situation? What if we've got a kind of a mixture? I've got a couple angles in this case. One of them's special. It's 90. And I want to find some missing sides. Of course, I could find that angle. We already did that a few minutes ago. But can we find those missing sides? Well, here we need another tool. And the tool we need is called trigonometry. So trigonometry relates angles and sides, as we'll see. So trigonometry is the study and application of the relationship between the sides of a right triangle and the angles. All right. So let's look at these here. Here we've got some triangles. Okay. What do we observe about these triangles? Well, They all have right angles, and they all have a 22.6 degree angle, just like my example we had a few minutes ago. So since they have right angles and 22.6, these guys are similar, right? So these are similar triangles as we've learned. And they're similar by angle similarities. So they all have the same ratio of sides. So since they have the same ratio of sides, we should be able to find this x like we've done in the past. We know 5 is to 12 as x is to 8. So we can solve that up pretty easily now. Cross multiply, and we have 40 equals 12x, and we'll divide by 12. Now we've got x is 40/12, which is 10/3. All right. So now you might notice if you compare these two that something actually doesn't quite fit. 5 to 12 is really not 4.2 to 10. If you look closely at that, this one's actually going to have to be more like 4.16, actually 4.17-ish approximately. And actually that's approximate too, because these are going to be irrational numbers. So, but the thing is that if we have a right triangle, we can definitely build a right triangle that has 5 feet and 12 feet on this side. And the angle will be close to 22.6. There is an angle. It's actually going to be an irrational number. But we need a way to relate these things, and that's what trigonometry does for us. So when we're working with right triangles, we've got to be able to identify the sides. So we're going to name some sides here. So identifying these sides of this right triangle, we've got, first we'll assume this is 90 degrees there. And we've got two acute angles, but whenever we're doing trigonometry, we're going to just kind of deal with one at a time in the most cases. And so we've got angle A, and so this longest side is called the hypotenuse. And we've seen that word before, dealing with Pythagorean Theorem. That's the hypotenuse. That's Greek for the longest side of a right triangle, I think. I don't know. But that's the hypotenuse, the longest side, opposite the right angle. And then we have two legs. These are the two legs that make the right angle. Now, these two legs kind of have a different relationship, though, to angle A. So if you're standing over here, here you are, a little self-portrait here. I guess it would be a self-portrait because I'm drawing it. But you're standing over here at A, and we have these two legs. We've got the leg that is connected to angle A. So this leg down here, it's connected. We're going to call that leg adjacent to angle A. So where is that leg? It is adjacent. Adjacent means connected. So this leg is part of angle A. This leg over here is not connected to angle A. It's all the way on the other side. So if you were standing over at angle A, you'd have to walk all the way over to the other side. We call this the opposite leg, or the leg opposite to angle A. So we have the adjacent leg and the opposite leg. All right. Now, when we wanted to talk about some special ratios like we just had, notice up here we were looking at the 5/12 and the ratio of these legs. And I went ahead and put it as this opposite leg over the adjacent leg. Opposite leg over the adjacent leg. Kind of like slope, rise over run. And so that's what we call the tangent ratio. We're going to give that a name. Okay, we're going to call that tangent ratio. If you want to find the tangent of an angle, you need the length of the leg that is opposite of angle A. And then you need the leg that is adjacent. And we're going to make a ratio because we know that in similar triangles, these ratios are the same. So the tangent of angle A is the length of the opposite leg over the adjacent. Now we're going to write that a whole bunch, so we're going to abbreviate it. We like our abbreviations. We're going to write that as op over adj. All right? Opposite over adjacent. Great. So when you see that, think opposite leg over adjacent leg. Okay? So if we have a right triangle, like here's a right triangle down here at the bottom, we've got all the sides we know. And if we want to find tan A, I know it's getting close to summertime, but we're not talking about the tan you get outside. That is the tangent. Even though we write it as tan A, it means tangent. And we find the tangent by the opposite over the adjacent. The opposite in this case to angle A. Well, which one's opposite? Eta is opposite. And which one's adjacent? Well, let's see. Is this 10 adjacent? Now remember, it's an adjacent leg. So yes, the 10 is connected to angle A, but it's not a leg. That's the hypotenuse. So it's 8 over 6. Whoops, I can't write. 8 over 6, which simplifies to 4/3. Always want to simplify our fractions. Okay? So we got 4/3. What about the tangent of B? So we got the tangent of B. We're still looking for opposite over adjacent. But now the difference is we're starting at angle B. So from angle B, where is the opposite? Well, opposite means if you're standing at B, you go all the way across. That is 6. And the adjacent leg, adjacent to B, is 8. So when we say opposite and adjacent, that means how it relates to the angle that we are working from. Angle A to start, and then angle B. And so we have two tangents, 4/3 and 3/4. So we've got this ratio called the tangent ratio. And now we want to actually use it. I was like, that's great. Okay, we can find this fraction. And we know that simple triangles have proportional sides. But now we're going to use our calculator. So you can use any scientific calculator to find tangent. Tangent is a ratio. And so I'm going to use Desmos here. Desmos is an online calculator. It'll graph and things like that. So if I want to find the tangent, now in Desmos you have to go to functions. On a regular scientific calculator there's a button that says tangent. So we want the tangent of 22.6. Now, I'm going to have a little problem to start here. There's two ways to measure angles. We can measure angles in degrees or radians. So what I have right here is actually not the tangent of 22.6. I need to go to the settings. I need to make sure that this is in radians. So to do that, we're going to measure angles. We're looking down here. We want it in degrees. You got to make sure your calculator is in degrees. That's very important. Okay, so we're talking 22.6 degrees. And so that comes out to be 0.4163. All right, 0.4163 there. Kind of small. Hopefully you can read it there, but that's what that is. So 0.4163, let's get that out of there, is our tangent. Okay. Now notice this here is 0.416259, so on and so forth. This is an irrational number. So you're going to have to round off, and when we write down trig ratios, we're going to round off to 4 decimal places, okay? So keep that in mind. All right? So all that means is that the tangent, which is the ratio of the opposite over adjacent, is about 41% or 41.6%. So if you remember, we had that triangle a few minutes ago that had a 22.6 degree angle. And this is 10. And so we're saying that this guy over here is 41%, or really 41.6% times 10. So this really should have been about 0.4163. Okay, is really what that should have been. All right, so we're getting into the world of irrational numbers. Lots of rounding, lots of decimals. Okay, and we can find the tangent of lots of angles. Let's find the tangent of 60. And really, you can think of it, our calculator just has this memorized. All right, is doing some calculations there. But tangent of 60 is 1.7321. Okay, so 1.727321. So you see, it's possible to have a tangent that is less than 1 and a tangent that is greater than 1. What about the tangent of 45? Well, let's try that guy. Tangent of 45 is exactly 1. So not all tangents are decimal values. Some ratios are exactly 1. Okay, and the reason for that is this. Remember a 45, 45, 90 triangle? If this is 45 and this is 10, well, this also has to be 10. So the tangent, which is the ratio of the opposite over adjacent, tangent of, let's call this A, is going to be 10 over 10, which is 1. And that's the idea of tangent. So your calculator can find tangent. And we can find tangent if we know the sides of a triangle, if we can see this triangle. So now how do we use this? Well, we're going to use this by doing this. If we want to find a missing side length, we need to decide how the given sides relate to the angle. Are they opposite, adjacent, or hypotenuse? We need to decide which ratio to use. Well, right now we only have one ratio, sine. We have tangent. We're going to talk about two others, sine and cosine, later. And then we're going to write this little trig ratio equation here. And then we're going to fill in the numbers that we know. All right, so those are the basic steps there. So let's try that out. All right, so here we had this same triangle we did earlier. And we did it with some proportions, all right? But now let's see. We know the tangent of angle A is opposite over adjacent. Well, do we know how big angle A is? I think we do. It's 22.6. So the tangent of 22.6 is the opposite. Well, how big is the opposite of angle A? Opposite goes all the way over here. So this is our opposite on the left. So the opposite is x. How big is the adjacent? That's connected right here. That is 8. Okay? Well, what is the tangent of 22.6? Well, we already found it out. It's 0.4163. Okay. So this is, we can replace it, 0.4163 equals x over 8. And this is now just an equation. It's got an ugly decimal in there, but this is nothing that's too strange, hopefully. We know we got x divided by 8. We want to get rid of that 8, so we can multiply both sides by 8, right? And so we're going to go to our calculator, multiply 0.4163 times 8. So bringing in our calculator, 0.4163 times 8 gives us 3.3304, which we can round off to 3.3 is fine. This problem doesn't tell us exactly what to round to, but it is rounded. Okay, so it should be about 3.3. Now, if we want a more exact answer here, instead of typing in the rounded there, the 0.4163, we can just leave it as 1022.6 times 8. And notice this is a little more exact there. And so this is more exact what it would be. But for most purposes, like building a house, that's good enough. All right? Now, this next problem, I'm going to change it a little bit here. All right? Let's pretend like we don't know this 41 here. And we know this angle here is 49. All right, now, of course, we could find that 41 if we wanted to, but a little different situation going on here. Now, let's call that angle A. And so now let's use our tangent equation. We've got the tangent of A is opposite over adjacent. And then we ask ourselves, well, how big is angle A? A is 49 degrees. We can swap that out. And then we got the opposite. Well, that's this guy over here. This guy is opposite because it's on the other side. And we've got the adjacent here. And the adjacent we don't know. And going to our calculator here, we have tangent of 49. And we can see that tangent of 49 is 1.150, and we'll round it off to 4. 1.1504. Okay, 1.1504. All right, so we can substitute that. 1.1504 equals 16 over x. Now, there's no tangent. There's nothing abnormal about this, something we're used to from algebra. All right. And how do we solve this? Well, if it helps, you can throw a 1 underneath this, make it a proportion, and we know how to solve proportions. We cross multiply, right? So we have 1.1504 times x equals 1 times 16, which is obviously 16. And now we can finish it off by dividing by 1.1504 on both sides. All right, and so we go down to our calculator. Now we're going to take 16, because 1 times 16 is 16, divided by that. So we have 16, let's zoom here. There we go. 16 divided by 1.1504. And that gives us 13.9082. Now, we could have also done this. We rounded as 1.1504. That came from tangent of 49. So, we might want to type in there the tangent of 49. And so that's a little more exact. Notice that in this case, you don't notice a difference. It's 13.9082, 13.9085. This one's more exact. And zoom in a bit there, you can see that. All right. But for most purposes, if we round this to 4 decimal places, then this answer will be fine, okay? And we'll round our answer here to 1 decimal place for our final answer. But keep 4 decimal places during the problem, and then when we get to the end, that's when we can round off a little bit more. So we ended up with 13.9. So that's how we can use tangent to find the missing side if we know the missing side is on the opposite or the adjacent. Well, let's do one last application and call it good. So trigonometry is something that is used all the time in careers out there. And here's some guys that came out to that property, that our new property that we did that addition that we saw a picture of the rake wall. And these guys are surveyors, and they are checking out to see how tall this bank is, to see if we are far enough from the river, to see if we're out of the flood zone, and the county inspectors require this. So surveying, these guys are measuring angles. They're seeing what the angle is here. They're trying to figure out the height. Not an easy thing to measure when you're talking this, so we need some trigonometry. So they're imagining some right triangles going on here to figure out exactly how far this is from the river and what the elevation is, and they can do all of this using trigonometry. So a real useful tool trigonometry is. So let's go ahead and try this out here. We're going to look at a problem. We're going to do some surveying of our own. Let's say we're going over here to the Empire State Building, and we want to measure the height of the Empire State Building. But we don't have a tape measure long enough, so you can't just kind of walk up to the top and throw a tape measure off the top of the building. But let's say this. Suppose we want to measure the height. We don't want to climb to the top, so we walk down the streets from the Empire State Building, and we're going to go ahead and go... let's see, we're going to go 1,215 feet away, all right? So we walked 1,215 feet away from the Empire State Building. And then let's suppose that I look up at a 50-degree angle there, all right? A 50-degree angle. So we know this guy right here, we're looking up at a 50-degree angle with the horizontal. And the question is, how can we figure out the height of the Empire State Building? Oh yeah, let's say that it's about 5 feet from the ground to my eyes, all right? So that might be useful here in a moment. So we notice that we're going to assume that the Empire State Building is actually standing straight up. We'll assume this is a 90-degree angle here. And you see the triangle that we've drawn here? So we've got that guy, this one right here, and that. Okay, so if I look up at the top of the the Empire State Building, I've got this line right here. That's my line of sight. If I look horizontal, I've got this horizontal line. And those lines make a right triangle. So we're looking for the height over here. That's x. Well, notice we have our tangent. So we're going to do the same thing we did a few minutes ago here. We're going to say the tangent of our 50-degree angle is equal to the opposite, which is the x, over the adjacent, which is 1215. And now we can solve this. I want to get that x there. So we're going to multiply both sides by tangent of, we're going to multiply by the denominator, right? 1215. So let's multiply by 1215. And these will cancel, leaving us with x. So then we go to our calculator. We'll go over here to Desmos again. Make sure it's in degrees, not radians, okay? And we want the tangent of 50 degrees. That's 1.19. And we're going to round that off to 1/8. Okay. And then we're going to multiply that by, we said 1215, right? And we got this answer, 1448. Now, there we rounded and retyped. As we saw before, it can be helpful, especially when you're dealing with large numbers like 1,000, 1,215, to go ahead and type it in. Now, in this case, we're gonna get about the same, 1448, and this one rounds to 1448. All right, so we round to the same thing. So 1448 is our number x. So the question is 1448 the answer? Is the Empire State Building only 1448 to the tippity top? Well, that's real close, but we're actually missing something. Remember, we said that the height to my eyes here is 5 feet. So if we said this whole thing was 1448, x is 1448. Let's try that again. This is 1448. If we want the whole height, we've got to add in this 5 feet. So the height is 1448 plus 5. And so that puts us at 1453 feet. That's our estimate there. All right, and I think that's close to what it is. So that's the idea. That's how we can use trigonometry to find the height. Now the question is, if you want to be a surveyor like these guys over here, you got to find a real accurate angle at a real accurate distance. That's why they're using some very powerful tools there. But all right, that's tangent. That's the introduction to trigonometry, and I hope that helps to understand how it works. But remember, the key, it's all about right triangles. Okay, got to have a right triangle to know that tangent is opposite over adjacent.